Today we will practice finding the slope of a line from 2 points without using a graph. We will look at a very important thing we must do right in order to correctly find the slope. So let's get started. So what is the slope of a line? Well, the slope is the rate of change of the line. And the rate of change is the ratio of two things that are changing. In this case, we're looking at a vertical change, or rise, and the rise is how much this line moves up or down compared to the horizontal change, or run. And the run is how much this line moves left or right. Previously, when we were finding the slope, we counted this change on the graph itself. So starting at 1 point, we counted the horizontal change. So that's 3, 4, 5, 6, 7, 8. So we have a run value of 8. And then our rise value was 1, 2, 3, 4, 5. And since we moved down, this would be -5. And this gave us a slope equal to the rise, -5, all over 8. So our slope is -5/8. Now, can we find the slope without needing to graph the line first? Let's take a look at what we're actually doing when we count this change. When we're calculating this run value, what we're doing is finding the difference between the two x values. So our run is going to be the difference between these two x values. So the first point is 4. So we'll go 4 minus, and then the other point is -4. It's -4, which is equal to 4 plus 4, which is equal to 8. And then with our rise value, we're going to find the difference between the two y values. Our two y values are -3 and 2. So we have -3 minus 2, which is -5, giving us the same values for rise and run we had previously, and so therefore the same value for the slope. This gives us a formula for slope. Slope is equal to the change in y values, or y sub 2 minus y sub 1, all over the change in x values, x of 2 minus x of 1. So this may be a new notation, y sub 2. So it's the y coordinate, so it's a y value, and then we have a subscript of 2. And when we say it, we're saying y sub 2, with the sub being short for a subscript. And it's used to indicate that these are the y values for two different points. So you have point 1, which in this case is -4, 2. And then we have point 2, which is 4, -3. And then we'll plug these values in. So y sub 2 is -3 minus y sub 1 is 2, all over x of 2 is 4 minus, then x of 1 is -4. And this gives us -5 all over 8. The same value we got previously. Instead of writing the word slope, we're going to use the variable m, because the variable m is traditionally used for slope. So let's practice a few. And in this case, we're going to find the slope of the line passing through each pair of points using two methods. So we're going to use the graphing method as well as that new formula for slope. So let's do the graphing method first. So we're going to start at a point, and I'll start with the leftmost point first. And we'll calculate the run and then the rise. So we have 1, 2, 3, 4. So we have a run value of 4. That's our change in the horizontal. And then 1, 2, 3, 4. Again, that's a change of 4, but this time it's in the negative direction. So our rise is equal to negative 4. Slope is equal to rise over run. So we have a value of negative 4 over 4, which is equal to negative 1. Now let's calculate the slope using the formula. So slope m is equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. It does not matter which of these 2 points we label as point 1 or point 2. When I'm looking at a graph, I typically take the leftmost point and label that as point 1. So this is x of 1, and this is y sub 1. So this we are calling point 1. And so the other point will be point 2. So we have x sub 2 and y sub 2. This is our second point, point 2. And now we're going to evaluate this formula with those values. Y sub 2 is negative 1. Minus, then y sub 1 is 3. This is all over. Well, x sub 2, that's 1. Then minus, then x sub 1 is negative 3. Negative 1 minus 3, that's negative 4. And then we have 1 minus a negative 3, so that's 1 plus 3. So this is equal to negative 4 over 4, which simplifies down to negative 1. We're finding the slope of the same line using 2 different methods, so we should get the same answer. So it doesn't matter which point you label as point 1 or point 2. What does matter, and what's very important to get right in order to correctly find the slope, is to always make sure you're subtracting one point from the other point. So in this case, here are the coordinate values for point 2. We have a y value of negative 1 and an x value of 1. And this here is point 2. And then we subtract from point 2 the y and x coordinates of point 1. A common mistake is to actually flip one of these values. So for example, let's say we're calculating this slope, and we grab that y sub 2 value of negative 1, and then we subtract from it y sub 1, which is 3, all over. Now the next step should be to grab x of 2, which in this case is 1. But by mistake, you grab the wrong x coordinate. You grab negative 3. So we have negative 3 minus, and then the other x coordinate of 1. When we do this math, we get negative 4 over negative 4, which is 1. So we have that same value of 1, but in this case it's positive, whereas the correct answer is negative. So if you do make this mistake, your slope will have the opposite sign. But if you quickly check and see, well, I've got a positive slope, so my line should be going up as I move from left to right. And that's not the case here. You can identify that you made a mistake somewhere and go back and check your work. And this is a common error, grabbing the y coordinate from one point and then the x coordinate from the other point. Now for this next example, I didn't give you the points. We're going to have to find it from the graph. So we have negative 2 -1 for this first point. Now I will have this be the first point again. So this is x of 1, and this is y sub 1. And then the second point is 4, 4. So this is x of 2, and this is y sub 2. So let's first calculate the slope using the graph. So we have 1, 2, 3, 4, 5, 6. We have a run value equal to 6, and then a rise value of 1, 2, 3, 4, 5. Rise equal to 5. Slope is equal to rise over run. So our slope is equal to 5/6. And now using the formula, we have m equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So y sub 2, that's 4, minus y sub 1 is -1, so minus a -1 all over x sub 2 is 4 minus a -2. So this is 4 plus 1 all over 4 plus 2, which is equal to 5/6. Again, positive slope, and our line goes up from left to right. Now we're just going to use the formula to find the slope of a line passing through a pair of points. For the first problem, we have the points 2, 5 and 3, 9. And I'm just going to go from left to right. So the first point listed will be point 1, and the second point will be point 2. I'll label my x and y coordinates. So this is x of 1, this is y sub 1, and then we have x sub 2 and y sub 2. And our formula is the slope m equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. Again, I'm going to rewrite this formula each time because it really helps me remember the formula and to make sure I'm evaluating at the correct points. So y sub 2 is 9 minus y sub 1 is 5 all over x of 2 is 3 minus, and then x of 1 is 2. Then doing this math, 9 minus 5 is 4, 3 minus 2 is 1. We get 4 over 1, and that's equal to 4. So the slope of this line is 4. Next, we have the points -2, 0 and 0, 4. Again, I'll label each of these coordinates. So this is x sub 1, this is y sub 1. And for the second point, we have x sub 2 and y sub 2. The formula for slope is m equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Y sub 2 is 4 minus y sub 1 is 0 all over x sub 2 is 0 minus a -2. So now we have 4 minus 0, that's 4. And then 0 minus a -2, so that's going to be +2. 4 divided by 2 is 2. So we have a slope equal to 2. For the last problem, we have the point 20, 8 and 9, 16. So x of 1 is 20, y sub 1 is 8, x sub 2 is 9, and y sub 2 is 16. Using that formula for the slope, so we have y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And then evaluating at those values, y sub 2 is 16 minus y sub 1 is 8, all over x of 2 is 9 minus, and then x of 1 is 20. 16 minus 8 is 8. And then 9 minus 20 is negative 11. And then I'm just going to rewrite this. I'm going to bring the negative sign out front. So we have negative 8/11. Our slope is equal to negative 8/11. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 3 problems. So in each of these cases, I did treat the first point listed as point 1. So this is x of 1, and this is y sub 1. And then the second point had the coordinates x sub 2 and y sub 2. So for the first pair of points, we get a slope of 11/2. For the second pair, 4/3. And for the third, negative 1/26, or negative 1/26. Continue practicing finding the slope of a line from 2 points, and I'll see you in the next video.